So in this video, we're going to talk about inverse function notation, but we're going to talk about it with expressions. So before you attempt this lesson, just make sure you're comfortable with inverse function notation in general, and also function notation with expressions. All right, so recall that inverse function notation is when we put this little -1 next to our function name. All right, so that lets us know we're doing the inverse, the original function in reverse. And also just remember this relationship: if f of a equals b, then f inverse of b equals a. The important thing is these things just flip places whenever I go from the inverse to the original, or vice versa. All right, so as long as you're flipping the x and y values whenever you're talking about your inverse, then you're doing it right. All right, so first, again, let's just quickly do an example with the original function notation. F of x equals 2 plus 3x. What is f of 3? All right, well, that just means I put in 3 for my x value and simplify to get 11. All right. You should already know how to do function notation with expressions. All right, just plugging a number in for your x. All right, what if I have the same function, but now I want to find f inverse of 8? All right, and there's a bunch of different ways you can kind of think about this. One way to think about it is f inverse of 8, let's just say it equals some value like, no, let's just use a. If f inverse of 8 equals a, if I switch that to the original, that means f of a equals 8. And we've done problems like this before when we're talking about function notation with expressions. F of a is going to be 2 plus 3a, right? Whatever is in the parentheses, replace the x. And there's nothing special about the letter a. I just picked a because it was first in the alphabet. All right, but that gives me that expression 2 plus 3a equals 8. And now I just solve this equation. Subtract 2 from both sides and divide by 3. That's my final answer. F inverse of 8 equals 2. And the reason for that is if I put 2 into my original, I get out 8. But really, these inverse ones with expressions are basically just solving an equation. All right, you set up the equation correctly and then just solve it. All right, one more example. All right, g of x equals 3 minus 5x, g inverse of 12. All right, so another way to think about it, different than the last example, is just knowing that when I compare this to my original function, this is my y value. And I also know with function notation, g of x equals y. So both these things are representing y, so they have to be equal to each other. So you just go straight from here to this equation, and now I have to solve it, subtract 3 from both sides. Divide both sides by -5. And I get 9 equals x. All right. So that is my answer. G inverse of 12 is -9 over 5. All right, one kind of thing I did, this negative here, you can put this negative in the front like I did there, or you can put it back on the top like I did there. All right, these negatives can kind of just move around as long as it's just with numbers like that. But the important thing here is when you're doing this inverse stuff with expressions, really just setting up an equation and solving it. All right, so here's one for you to try on your own. H of x is 8 minus x. Find h inverse of 7. All right, so I'll show you the answer in 3, 2, 1. And the answer is 1. H inverse of 7 is 1. All right, for a bunch of different reasons, but I kind of did it similar to the last example. All right, this is y, and this is also y. So they're equal to each other. Solve that equation. You get 1 for your answer. All right, so go ahead and practice finding the inverse function using expressions. And just know we'll talk about more types of problems as we learn to solve more types of equations. Right now, we really only talked about solving linear equations. So there's not a lot we can do with inverse functions. So you see a lot of the examples are similar. All right, but as we do more stuff throughout the year, we'll learn how to do more inverses using expressions.